Page 2. Compute the slope of the line. Blah, blah, blah. So take these points. And remember how this goes? Just subtract y values on top, any order you like. So I decide I'm going to do 0, take away, -1. Watch your signs. Since I started with the 0 for the y, I got to start with the 3 for the x. 3, take away 7 on the bottom. 3, take away 7. Make sure you've got x values, 3 and 7 are x values, and y values. 0 and -1 are the y values. So take away -1 becomes +1. 3 take away 7 is -4. So the answer is 1 over -4, or -1/4. Subtract here. You want to be really safe and cautious. Arrange this vertically. Got 2q to the third minus 3q squared. And there's no q to the first term. I'm going to push the +1 all the way over. Then it says take away this. It's take away, so change it to add the opposite first. So add the opposite amounts to make that +3q squared plus 6q and +3. Okay? So instead of subtracting, we're adding the opposite. So I just write these things underneath now. 3, whoops, putting in the wrong place. After all that talking, 3q squared, 6q, all by itself, and then a +3 at the end. So we get a 4 and a 6q, and the q squares cancel, and 2q to the third. And don't forget plus sign here because it's a positive 6q. 2q to the third plus 6q plus 4. Okay? Don't get fooled by combining these. They're not like terms. That's third power, that's second power. Okay? Multiply this together. Well, this is just a bunch of stuff being multiplied. It's 6 times x to a power times y to a power times z times 5 times x to a power times y to a power. And my point is it does not matter what order we multiply in. So since I'm explaining this, I'm going to rewrite this in a more useful order, putting the numbers, the coefficients alongside each other, putting the x's alongside each other, and the y's, and the z is all by itself there, right? So I got the 6 and the 5, x cubed, x squared, y squared, y, and the z. And now we simplify. 6 times 5 becomes a 30. X to a power times x to a power. This is where we add the exponents. Don't forget this is a y to the first power, 2 plus 1, 3, and the z does not change. Okay? Now this, you could look at this as a FOIL problem, or you could use the difference of squares idea shortcut. You just square this, and put a minus sign in the middle. 16p squared minus 49. That's going to be our answer. But if you don't follow that shortcut, just do this. Multiply 4p times 4p, get 16p squared. Then 4p times minus 7, you get minus 28p. We've used up the 4p, now we use the 7. 7 times 4p, that's plus 28p. And 7 times minus 7, minus 49. Collect the like terms. They're opposites, so they disappear. So what did I tell you? 16p squared minus 49. Okay. Simplify this fraction one piece at a time. First we'll do the coefficients, then the m's, then the n's. So for the coefficients, we reduce the numerical part by thinking what goes evenly into both the numbers. Well, 2 does. If I divide 2 by 2, I get 1. So I can put a 1 on the top, and -12 divided by 2, I get a -6. Okay, then for the variables, where's the bigger power of each variable? That's where it stays in our answer. This is a m to the 1 and -3 up here. So 1 beats a -3. And now we subtract the invisible 1 that's there. 1 take away -3 becomes +4. How about the ends? A 9 beats a -7, and 9 take away -7 becomes +7, so we get n to the 16. So we took care of the coefficients, the m's, the n's, that's everything. So it turns out we did need the one on the top. We do need the one on the top because the answer is not this, it's 1 over all that. And lastly, on page 2, use the distributive property, multiply everything in the parentheses by 2x to the third. So we get 6x to the 5th minus 6x to the 4th plus 2x to the 3rd. And that's it for page 2.